Alrighty, good morning. The next thing you need to look at today is looking at finding critical regions and critical values. Now, what we're talking about is critical region and critical value. We'll start off with critical region. These are probably actually the wrong way around. And I've got them written in there as well, just so you don't have to see me write it again. Critical region of any probability distribution, and especially a binomial distribution, it's the region in which you would reject the null hypothesis if the test statistic falls within that region. Okay, so it's the point where, for example, if you're testing at the 5% level, you're looking at where your probability is at that 5%. Okay, anything from 0% to 5%, that would be your critical region. The critical value is the first value inside the critical region. And remembering with a binomial distribution, you have discrete values, so all integers. So it's an integer value, okay? We don't talk about it being, 4.5 or 6.5 or whatever, okay? It's a whole number. All right, so I want you to have a look at this. This is a distribution where you've got 7 fairly average soccer players with the following probabilities of making a penalty shot. The distribution is binomial, and out of 10 shots, they have a probability of scoring, a certain amount of goals. All right, and it ranges from a probability of 0.2 to a probability of 0.5. And the table shows the cumulative distribution of them scoring n goals out of 10 trials. Okay, so say, for example, we're running a hypothesis test of this situation, and say we want to test that the probability that our H0 is equal to 0.4, and we're testing for alternative hypothesis that it would be greater than 0.4. Okay. Okay, so this is just an example. So if we look now, if we take the 0.4 probability and we look at this, where would we reject our null hypothesis? So we would reject anywhere where it's greater than 0.4. So we're looking at greater than values, and we're looking at, for the first point, where our greater than value dips below the 5% mark. So what we mean by this is at 10 goals, right, we have a 100% probability that they score 10 or less goals, which makes sense because they're making 10 or less attempts. But their actual probability that is equal to 10, so if I do this on my calculator, where's my distribution? Binomial PDF. Sorry guys. Binomial PDF. So 10 trials, okay, probability 0.4, and I want 10 successes as well. Okay, that would give me a probability overall. It's going to be really small. Okay, so 1.04 times 10 to the power of negative 4. Okay, so that, if we got 10, if we looked at x equals to 10, we would reject our null hypothesis, wouldn't we? Because that probability fits in between the 0 and the 5%, so we would reject that as our null hypothesis. If we looked at, so this falls within our critical region. If I just change this now I'm going to change that to 9. So now we're looking 10 trials, 0.4, but 9, my probability is 0.0157. And if I add these together, so that's my probability of 10 plus my probability of 9. Okay, I still get 0.0167. Now that's still less than 0.05, so it's still within my critical region. Okay, so I'm going to do the next one. I'm going to look now at 8. So now I look at my probability of 8, and I get 0.0106, and I'm going to add that onto my 10 and 9 cumulative probabilities. So here, okay, that's my next one. So 0.01, so still less than 0.05. So 8 still within my critical region. Now I'm going to add on 7. And I'm going to look at 7. Now this one's 0.04. So obviously when we now add this one onto the 0.01, this is probably going to, now this falls outside our critical region. Okay, so 7 is not part. So if I write this in here, my probability, okay, that x is greater than or equal to 7 is bigger than, why is my eraser not working? Oh, now it is. Okay, is greater than 0.05, but my probability where x is greater than or equal to 8, that was less than 0.05. All right, and what that's telling me is that what this is telling me is that x is greater than or equal to 8 is my critical region, because that will lead to me rejecting the null hypothesis, and x equals to 8 is my critical value, because that's the one that kind of, that's the first value within that critical region. Okay, so hopefully that kind of makes sense. If we look back at this table, you can see that if the critical region changes for the different probabilities. So if we look at, where's my highlight? I use a highlighter. Highlighter, pink, nice and easy to see through. Okay, if we look at 0.2, where the probability is much smaller, I want to look at the first time when my probability dips below. So this would be my null hypothesis is equal to 0.2, alternative hypothesis greater than 0.2. Okay, I'm looking for the first point where it would dip below 5%. So here I've got 100% probability, 0.99, 99. So they're still, if you look at the 1 minus from that, that's still all going to be less than 0.05. Okay, this one, 0.01. Now we get up to 0.96, and then after 0, so that's still less than 0.05, because if we do the 1 minus 0. I think it was 967. Okay, we can see that that's still 0.033, but my next value is 0.879. Now that's at 10, 13, almost 13%. So that one's going to be accepting the null hypothesis. Okay, so to reject the null hypothesis, any value that's 4 or greater will allow us to reject that. And the probability where x is equal to 4 is your critical value, because that's the first one in that region. Okay, so hopefully that makes sense. All right, this first example. So we've got a single observation is taken from a binomial distribution, with 6 trials and a probability p. The observation is used to test that h0 is the probability is equal to 0.35. And the alternative hypothesis is p is greater than 0.35. So using a 5% level of significance, find the critical region for this test. Now, just give me a second. I'm just going to pause this video so I can get the Casio calculator up to show you how you should do this on your own calculators, okay? Alrighty, so the first thing that we do is we assume h0 is true, much like when we're doing an actual hypothesis test. So our distribution is binomial, 6 trials, 0.35 probability. Now, we're looking at where our alternative hypothesis is where the probability is greater than 0.35. So, to find the critical region for the test, what we're doing is we're looking at where our value is going to be greater than. Remember, because greater than if you're looking at a greater than probability for your alternative hypothesis, you look at greater than values for your critical value, for your x test statistic as well. Okay, so we're looking at the probability where x is greater than or equal to now something. Now we don't 100% know what this is. And so now we just need to do the calculation, and it's a bit of kind of trial and error, but you will get used to kind of thinking about what values to use. So you're using binomial CD, and we're wanting to, actually, sorry, I should do binomial CD with a list. That's probably the best way to do it. Hang on, just let me go back. So if I go in here and I go binomial CD and I use list, then hopefully we can get now x 1, 2. All right, I just figured out how to work this. So I'll show you again. So if we go into distribution and we want binomial CD, now if you pick list, Now what you want to do is you want to type in there all the x values that you want. So for this case, we're looking at your number of test statistics, or number of values. You're looking at 6 because you've got 6 things. So I've typed in 0, 1, 2, 3, 4, 5, 6 there. Now if you press enter, it's going to tab across and it'll say, it'll ask you for your number of trials and your probability. So here I've got n for my 6 for my number of trials, my probability 0.35. So I input that, and then you can see there you get all the probabilities. So here we're looking for the first value where we get that probability being bigger than 5%. And remember, we're looking at greater than values, so you're going to look at the ones where it's going down from 100. You want 5% less than 100. So here, if we start off at 1, you can see that the probabilities kind of drop down quite dramatically from there. So probability that x is greater than or equal to 6 is 0.99. Okay, probability x is greater than or equal to 5, 0.997. Now, if we look at the probability where x is, we'll do the probability that x is greater than or equal to 4. Okay, that's 1 minus the probability that x is less than or equal to 3. So if we now look at that, the probability that x is less than or equal to 3 is 0.8825. Okay, so if we do 1 minus, let's do it on my other calculator, so 1 minus 0.8825, okay, that's 0.1175. So that would, if we got that as a score, we would accept our null hypothesis, and nothing would come from that. If we look at the probability that x is greater than or equal to 5, okay, that's 1 minus the probability that x is less than or equal to 4. So now we are doing 1 minus 0.9776. Okay, that's 0.0223. So this one, if we got 5 or greater, in that case we would reject our null hypothesis. So x is 5 or x is 6 is our critical region. Okay, the second part of this question says state the actual significance level of this test. And the actual significance level is the probability in which you would reject the null hypothesis. So for our probability that x is greater than or equal to 5, okay, we know that's 0.0223. So our actual probability is 2.23%, because anything less than that we would reject, even though we're testing at the 5% level, because it jumps straight from 11% to 2%, our actual significance level is 2%, okay, or 2.23%. Alrighty, for a two-tailed test, okay, we have to consider the probability of the tail in each case. So this one says a random variable x has binomial distribution B40p. A single observation is used to test h0 p equals 0.25, h1 p equals not equal to 0.25. Using the 2% level of significance, find the critical region of the test. The probability in each tail should be as close as possible to 0.01. So now we're looking at the top end and the bottom end. Okay, so both at either end equal to 0.01. Now, I'd like you guys to have a go at this on your own. I'm going to write up the answer just because I'm running out of time on this video. So I'll write it up and you can check it. But pause the video, have a go at it, and then check your answer when you're done. Okay, so here's the answer to part. So you should be able to see, you should have got x is less than or equal to 3 for 0.047, 4 being a little bit too big, and likewise 19, greater than 19 being a little bit too big, so then your critical value is less than or equal to 8. Oh, no, sorry, less than or equal to 18 being too big, so your probability, so greater than or equal to 19 should be what you get. Now, for the last bit of the question, which is to state the actual significance value, now you're going to put the two parts together. So we're using 0.01017 plus 0.0047, add those together, and that gives you your actual level of significance. Okay, this is about to die, so have a go at 4B for critical values, and let me know if you've got any problems. All right, see you later, bye.